Okay, so we have this question here, and it says a car is traveling along a straight horizontal road. The car takes 120 seconds to travel between two sets of traffic lights, which are 2,145 meters apart. The car starting from rest at the first traffic light accelerates uniformly for 30 seconds to a velocity of 22 meters per second. The car maintains this velocity for t seconds before decelerating uniformly to rest at the second traffic light. So first thing we need to do is to sketch a velocity time graph to show the motion of the car between the two traffic lights. So we see we have a setup of the scenario. So the car is going to travel from this traffic light right here towards the second traffic light, and it will be traveling a distance of 2,145 meters. And the question says that it takes 120 seconds to go between the two traffic lights. So what we're going to see now is that in order for us to sketch our velocity time graph, let's just sketch out our two axes. Alright, so we see we have our sketch right here. Let's just put in our origin. So it says that the car would start from rest, right, and accelerate uniformly for 30 seconds up to a velocity of 22 meters per second. So we can show that by considering that, okay, once the car is accelerating uniformly, we're going to get a straight diagonal line. So let's just put that in. So we get a straight diagonal line to show the acceleration for the first 30 seconds, like that. Then it says that the car would have traveled, the car maintains its velocity for t seconds. So it's going to continue. So we can show that by a horizontal line, right, for t seconds, which will take us up to about here, and then it's going to decelerate uniformly towards the second stoplight. So we can show that, right, like about that. So that's what we're going to get. So that would be our sketch. So let's just put in some information here. So let me just consider, right, so the velocity here would be 22. So we're going to put that in shortly. Right, and then this now go straight down. Alright, so that would be our velocity time graph. So let's put in some information. So the velocity, well, the time here is going to be 30, right, and the velocity would be 22 meters per second. Now, the time at this point right here is unknown because we don't know the time it takes to travel at the same velocity after it would have reached 22 meters per second. So let us say we call this t plus 30. And then now it's going to take a total. So the question said that it would have taken 120 seconds. So the time right here to reach the second stoplight, where it is at rest, would be 120 seconds. So that's our velocity time graph. So let's see what's next. So it says now we're to determine the value of t when the car was traveling at constant velocity. So we need to know the time, right, during this interval. Let's just kind of make it a shaded area. So we need to know the time here. Now, if we know the distance traveled here, we can actually find the time. Right? If we know the distance traveled here, we can actually find the time because we're going to know the velocity. And the velocity is constant, so it's 22 meters per second. So let's say, we consider this section right here. Let's say for the first 30 seconds, we want to know, okay, what's the distance covered here? Let's say we look at that. So now, what we're going to see now is that from a velocity time graph, the distance traveled is given by the area under the graph. So in this case now, for the first 30 seconds, we have a triangle. So we're going to find the area of a triangle. So we say area A is equal to a half base times height. Now, looking back at our diagram, the base is from 0 to 30, and the height is from 0 to 22. So we can say this will be equal to 30 times 22, and we take the half of that, so we divide by 2. Then taking the calculator, we could say 30 times 22 divided by 2 gives us 330 meters. So that's 330 meters. So it would have traveled 330 meters from 0 to 30 seconds. Now, because we don't know this time right here, right? But we do know the time it takes to go to 22 meters per second, and we know the time for the complete journey. So let's say we consider, so if we consider the total distance traveled here, we could determine this distance here, but since this distance, the total distance is 2,145 meters, if we then subtract the distance traveled in the first 30 seconds, we can find the distance traveled from 30 to 120. So let's say that would be 2,145 minus 330, which would give us, let's take in the calculator, that would be 2,145 minus 330, and gives us 1,815 meters. So it therefore means I know that the area of this trapezium would be the value we just calculated, which is 1,815 meters. So if we say now, the area for trapezium A is equal to a half A plus B times the height, we get A would be from 30 to T plus 30. So if we subtract T plus 30 from T plus 30, we're going to get T. So we're going to get T plus B would be from 30 to 120, so that's 90, multiplied by the height, which is 22, and we divide that by 2, and again that would be equal to the area, which is the distance traveled right here. What we just found out to be 1,815 meters. So if we transpose, we're going to get 2 times 1,815 divided by 22 is equal to T plus 90. So simplifying, we can say, taking the calculator, we say 2 times 1,815 equals divided by 22. So we're going to get 165 is equal to T plus 90. So therefore now, T is equal to 165 minus 90, which is 75 seconds. So that would be our question.